chapter 9 is all right triangle stuff. This first section is probably the hardest. The way they show you in the book is the hard way to do it. I'm going to show you the easy way to do it. So you're going to want to watch this instead of going back to look. If you've got a big right triangle with an altitude drawn, what happens is it forms 3 right triangles. It's got this one right here. It's got triangle ADB. And then it's got this triangle BDC. And then it's got the big triangle ABC. Okay? So all 3 of these are proportional. So it kind of ties into what we just did in chapter 8. The hard part is they're not all lined up the same orientation, so it's hard to see what's proportional. This piece, that's a bad drawing. And this piece are all proportional. AB, AC, and BC are the corresponding pieces. And then this piece here, you can see it's the shortest and the shortest and the shortest. So AD, BD, and AB again are all proportional or corresponding. And then the third sides would be this side, and this side. So again, it's really hard to write the proportions out just because it's hard to see what corresponds to what, because they're turned and flipped and rotated. So, this is how you do these. First of all, before we do it, there was just a small lesson finding the geometric mean of 2 numbers. You probably have forgotten it, but anyway, if you've got 2 numbers and you want to find the geometric mean of them, you do a proportion. You just put x as the geometric mean, you put that kitty corner, and then you put these here. So x times x equals 4 times x. So then you just square root it. Remember doing those? No? Okay, so it's proportions again. It was like in section 8.2. So when you have these triangles, the geometric mean is what you're going to use to find the different values. So there's 3 different types of proportions you can write with these. This is a geometric mean. This is a geometric mean, and this is a geometric mean. Okay? This piece, and this piece. The numbers we use in the rest of the proportion are this piece, and the whole piece. Okay? So when you look at this picture, there's 1, 2, 3, 4, 5, 6 different lengths on it. Ever understand what I'm saying? Okay. There's this piece, this piece, this piece. There's 3, 4, 5, and then of the big triangle, there's this whole thing. So, if you're looking for x, first of all, when you set these up to figure out x, you write a proportion. X is a geometric mean, y is a geometric mean, and z is a geometric mean. So it doesn't matter if you put them here or here. You just got to put them so they're kitty corner of each other. All right? Then I'm just going to make up some lengths here. We'll say this is 4 and this is 10. Okay? If it's this, this is something you're going to have to memorize, but when it comes down, it cuts this into 2 pieces. So the rest of the proportion is this piece and that piece. Okay? So this goes in there twice. This piece and this piece are the other 2 numbers. So the way you solve them is x squared equals 40 So we got to square root it, and all of these we round to the nearest tenth. So that would round to 6.3. So when it's this altitude, you put each piece. Now when it's this one, we use the piece that's hooked to it and the entire length. So it's 14. We can't use 4 and 10 again because then we'd get the same answer as this. Then it'd be the same exact proportion. So when it's one of these legs, you use the part hooked to it over the whole thing. So this one, it's y squared equals 4 times 14 is 56. So we square root it, and you get 7.5. And then z is the same type of pattern as this one. You use the piece hooked to the z, which is 10, and then the entire length, which is 14. So you end up getting 3 different proportions. So this one, z squared equals 10 times 14, 140. So we got to square root it, and that's 11.8. So again, what you got to remember is the geometric mean. You put it in 2 spots, and then the other 2 numbers you put in here. All right? So let's do some examples of that. Okay, this one is one of the harder ones to begin with. In order to find h, which is what they're looking for, it's a geometric mean, so you put it in there twice. But we would have to put this piece and that piece. We don't know either one. You could call this x and this 11.7 minus x. That's true, it's just, can you solve it? No, because you have h's and x's in there. So this is one where you have to first find what this is or that before you can find h. So remember, this is a geometric mean, right? So I can put that in there twice. And when I use this leg, I got to use this part that's hooked to it, which I could call what? X. And then it's over the whole thing, 11.7. So on this one, the examples I gave you over there, the geometric mean was missing. Here we knew the geometric mean. So it's a simple one to solve. It's just 11 times 11 divided by 11.7. $10.3. Okay. So now that I know that's 10.3, I can figure this out because the whole thing's 11.7. That would be 1.4. Now I can find h. This is a geometric mean, so you put it in there twice, and then when it's this middle piece, you put that part and that part. So this one, it's h squared equals 10.3 times 1.4. 14.42, which I have to square root it, and it'd be 3.8. So again, they show you here, you could write proportions if you can tell what pieces are proportional, which again, it's really hard to visually move all that stuff around in your head to see what piece corresponds to what. So this is always the easiest way to do it because it works every time on these. So here they want AD, so that's the X. So we use what they're giving to us. This is a geometric mean, so it goes in there twice. And again, it doesn't matter if you put them this way or that way. And then when it's this piece, you got to put this part and that part. So it's just 24 times 24 divided by 18. and it's 32. Here, this is a geometric mean, and they're looking for NQ right there. So again, you put the geometric mean in there twice, and when it's one of the outside legs, you put the piece it's hooked to and the entire length. Okay? So it's 10 times 10 divided by 26. .8. So once you set them up, they're simple to do. It's just you got to remember which one is the geometric mean that goes in there twice, and then what are the other two numbers you got to use. So remember, the geometric means are this, this, and that. In this case, they're looking for that right there. So that goes in there twice. And then when it's this piece, you use each part, 8 and 4. When it's one of these outside ones, you use the part hooked to it over the entire length. So this is x times x squared equals 8 times 4. So I got to square root it, and that's 5.7. So here's one of them where they're looking for the outside leg. So that goes in there twice. When it's this one, you use the piece hooked to it and the entire length. So y times y is y squared equals 8 times 2 is 16. When you square root it, it's 4. Everyone got the idea of it? Yeah. This is one you're going to see quite often. This is a geometric mean, and if you notice, it's cut into 2 equal pieces. Yeah. What that means is it's isosceles. This length would equal that if we were looking for it. But we'll see what happens here. T goes in there twice because it's a geometric mean, then you put this and this. 17 times 17 equals t squared. So when I square root it, I get 17. If that's ever split into 2 like that, this length, the height will equal what each of these are every single time.
When are you going to have the book today?
The test? Tomorrow when the others take it. So here is a geometric mean. And you put the piece hook to it and the entire length. So t squared equals 9 times 15 is 135. So we square root it. 11.6. And on this one, z is the geometric mean. So when it's a leg, you put the piece hook to it and the entire thing. So z times z is z squared equals 5 times 18, 90. So you square root it, and it's 9.5. Remember when you round these now, just in case some people have forgot. When you round to the nearest tenth, you look at the number after it, right? Everyone here hopefully remembers how to round?
Yep.
It's 5 or greater, so that rounds up. Okay. All right, so that's what we're doing.